Last week when we did the first part of 2.7, we talked about combining functions. We added them, we subtracted them, we multiplied, we divided. They gave you two functions, you added them together, just combine like terms. Same thing with subtraction, you just have to distribute the negative, you know, all that good stuff. So what we're doing now, you have to, hold on a second, I gotta write something down. You have to understand that this is a different thing. A composition of functions is when you take one function, one entire function, and plug it into another one. So the way that compositions are written is like this down here at the bottom. Do you see where it says F and then it looks like an O of G? Looks like fog. That's not a multiplication symbol, guys. That's the symbol for compositions. That's saying that G is a function of X. You're taking whatever is closest to the X and plugging it into the other function. I always tell my students to work from the inside, write this down, work inside, out. So whatever is closest to the X, what they're telling you here is take the entire G function and plug it into the F. So everywhere you see an X, you plug in the entire G function. It can also be written like this. This says take the G and plug it into the F. Now your algebra skills, you got to just pay attention here. There's going to be domain. They're going to say state the domain. When is there a domain restriction? Give me an example of when there'd be a domain restriction. When do you have to worry about, oh geez, X can't be a certain number when there's a number where, Marco? Okay, you can't have 0 in the denominator. Good. When's another time that we have a domain restriction? Think about square roots and stuff. Can you take the square root of a negative number? No, so you got to be careful of that. And we'll talk more about that in a second. But that's when you're going to have your domain restrictions. It's going to be when there's a denominator that has a variable or when you're taking an even root. So let's just practice. This next slide is just kind of using a picture diagram to show you. Okay, finding compositions of functions. Do you guys see the two functions that they gave us? People at home, you see the two functions they gave us. They gave us F and they gave us G. Everybody see that? Thank you. Okay, I'll just talk to everybody in here. So A says find F of G. F of G of X. So tell yourself you're going to take the whole G function and plug it where? Into the F. Okay, let's look at our two functions. Are there any domain restrictions? Is there a variable in a denominator? No. Is there a variable underneath the square root? No. Is there a square root in the denominator? No. So my domain for letter A, I can already say what it is. What's my domain? How do I say I can use all the numbers? No, all the numbers in the world. Negative infinity to positive infinity. That's my domain here. So now if I'm going to take the G function, so I'm going to write, okay, F is X squared and G is X minus 3. They're telling me to take the G, this is how I would do this, take the G and plug it right there into the F. They're not telling me to plug any numbers in, they're just telling me to plug one into the other. So instead of X, what am I plugging in here? X minus 3. And then what's the rest of the function? What do I have to write? Squared. And now we can evaluate that. X minus 3 times X minus 3. FOIL that. X times X is X squared. X times negative 3 is negative 3X. Negative 3 times X is negative 6X. And negative 3 times negative 3 is 9. So F of G equals this. The easiest way to do this, so you guys don't make mistakes, is to write everything down. Like for B. B wants G of F of X. That means they want me to take the F and do what? Plug it into the G function. So write down what the F function is. Again, it's X squared. The G function is X minus 3. So they're telling me to take the F, here's my F, and plug it in to the G. When I do that, guys, instead of X, what do I write? X squared, and then I finish the function. So it's what? Minus 3. So g of f equals x squared minus 3. Now the second one is easy. You've already combined the functions, correct? What is b telling you to do? Plug in those numbers. All right? The thing that you have to do here is you have to look at this problem, and I'm going to say, okay, here is my b. It's saying f of g of 5. The exact same way that we just did this problem above with x, we're going to do with 5. They're telling me to plug 5 into g. Everybody see that? Okay, so let's do that. What's the g function? G of x is what? X minus 3? Right? So 5 minus 3 gives me what? 2. Now what do you think they want me to do with that 2? Plug it in to the f. So now I say, okay, well, f of x is x squared. So 2 squared is what? So f of g of 5 is 4. Mm-hmm.
Why didn't you just plug it into the f of g, like the x squared?
Okay, let's see if that works to be the same thing. If I've already combined them here, right? So Alexa says, well, wait, can we just plug it in? Well, let's see. If I say x, well, hold on. Okay, let's try that. So I have f of g of 5. So my f function x squared minus 6x plus 9.
Again, 100, 400, and portables should have reported to the gym. We asked that all freshmen teachers.
What's 5 squared?
200, 300,
25, right? Minus 30 plus 9. What's 25 minus 30? Negative 5 plus 9 is what? Do we get the same thing? Good. Good, good, good. The reason I didn't do that right off the bat, Alex, I was just going to show you that, but perfect, is because sometimes you guys will get a question and it'll just tell you this f of g of 5. It won't tell you to combine them first and then to plug in. So just depending on how they see it. If they give you a question and it says, go ahead and find one of the other and then plug a number in, you can do that. But sometimes they'll just tell you g of f of 2, and then you have to figure out what, you got to plug the 2 into the g and then plug it into the other one. Just depends on how the question's asked. But very good question. Here, since we've already combined them, how do I figure this answer out? I want to find g of f of, what do they want me to plug in? 7. So I have 7 squared minus 3. What's 7 squared? And 49 minus 3 is? What is it? 46. Good. Questions? This isn't crazy hard. It's just algebra. It's just a matter of keeping yourself organized. All right, let's look at the next one. Okay. They're saying from this example, you can see, look, if they ask you something like this, all right, in this question, what do they want you to do? Take the h function and plug it where? Into the g. And then once you do that, you take that answer and plug it where? Into the f, okay? I'm not going to give you anything on your quiz like that. I just want you to see what this means. Again, we work from inside out. So if it was written this way, you take the h function, plug it into the g. Then once you get the g function, you plug it into the f. Work from inside where? Out. Very important, guys. So let's look at the exact ones that they have here. Let's just find, I'm going to give you some stuff to do, all right? I see that there's questions here, but for number 1, let's do h of f of x. Okay, h of f of x.
All freshmen, teachers, and students should report to the gym at this time. Again, all freshmen, teachers, and students, please report to the gym at this time.
What this question is saying is to take the f and do what? Take the f and do what? plug it into the h. So I'm going to take my f function. So look, here's my h. So I'm going to take this and plug it right there. So instead of x, what am I writing? X over what? X plus 1, and then what? Plus 3. Is there anything else I can do there to combine like terms, anything like that? Yes or no? No, I cannot do anything else. That's it. Are there any domain restrictions, ladies and gents?
Yes,
Yes, how come?
because there's a variable.
In the denominator. So I have to say, let me figure out what x cannot be. So x plus 1 cannot be 0. So x cannot be negative 1. It could be any number in the world except for what? So how would I say that? How would you guys tell me it could be anything in the world except for that?
Negative infinity to infinity.
Negative infinity to what? What's the one thing it cannot be?
Negative 1.
Negative 1. And then what? Negative 1 to what? Infinity, right? It can be any number in the world except for negative 1. So I have to say, oh, wait. It can be anything but that. Everybody see that? Yes or
Yes.
no? Okay. What about if I said g of h of x? What am I going to do? Take what? Take the h and plug it into the g, right? So I'm going to take this h and I'm going to plug it right in there to g. So what would this look like?
So would it be like you just put
Did my air server just go out? Okay, so what would I do here? Take the h function, which is what?
x plus 3
Okay, so everywhere I see an x in the g function, I'm going to write x plus 3. And then what's the rest of the g function?
to the 10th?
To the 10th power. Now, I'm not going to have you guys do this, but what would this mean? What does it mean if it says x plus 3 to the 10th power? You would FOIL it 10 times. You would have 10 of those parentheses FOIL it out. I'm not going to have you do that. Excuse me, I want you to understand the concept here. What about if I had hold on. Okay. F of h of 2. Did we already do this one since we did h of f? Now I have f of h. Did we already do this one? No. Right? This is different. This is saying to take the h function. Right? What am I going to plug in here for the h function? 2. Right? So I have, well, actually, you know what? Let's do this with x and then we'll do it with a number, just so you guys can see. We'll do it like this first. This is saying to take the h and plug it into the f. So I'm going to take the h and plug it into the f. So what would this look like? Everywhere I see an x, what do I put? If I'm taking the h function and plugging it into the f, what would this look like? In the numerator, I'd have x plus 3, right? Mm-hmm. And in the denominator, instead of x, I would have x plus 3 plus 1. Okay, stop right now for a second. Is there a domain restriction? What can x not be? Can't be negative 3. So your domain for this one would be everything in the world except for negative 3. Because what happens if it's negative 3? It'll make our denominator 0. Now if we simplify this, guys, we have x plus 3 over x plus 4, right? So if at the beginning, if I gave you the problem and I said f of h of 2, you don't have to combine them or anything. If you have a number, just plug it in. This is saying to plug what number into the h function? What number am I telling you to plug in? 2. So I'm going to say, okay, fine, 2 plus 3, so I get 5. Now with that answer, they want me to plug it in to the f. So now I take my f function, which is x over x plus 1, right? So I say 5 over 5 plus 1, and I get 5 over what? 6. Questions? Let's look at the last one. All right, it says find f of x and the functions f and g such that f equals f of g. Okay, I'm going to give you the g function is x minus 6, okay? And your f function, we'll just leave it like this, is the 4th root of x plus 9. Are there domain restrictions here? How come? Because of the square root. What do we need to know? Since I have a square root, what do you guys need to know? It has to be what? Cannot be negative. It has to be greater than or equal to what? 0 underneath the radical. So if I said to you guys, okay, so we'll do both of them. F of g of x, and we'll do g of f of x. Okay, so the first one I'm going to do is I'm going to take the g function and plug it into the f. So I'm going to take this g and plug it right there. So when I rewrite this, this becomes the 4th root of, instead of x, what do I write? X minus 6, right? And then plus 9. Correct? Mm-hmm. So if I work this out, I get the 4th root of what? What's x minus 6 plus 9? X what? Plus 3? Right? Negative 6 plus 9? Now when I talk about the domain, guys, my 4th root, since it's an even root, if it was square root, 4th root, whatever, that has to be greater than or equal to 0. So I would say the 4th root of x plus 3 has to be greater than or equal to 0. So 4th power, x plus 3 has to be greater than or equal to 0. X has to be greater than or equal to negative 3. How would I say that for my domain? How would you say it has to be greater than or equal to negative 3? What would your domain look like? Yep. A bracket, negative 3 to what? Very good. So now if I go the other way, if I say, okay, well, I'm going to take the f function and plug it in here, I have the f function, so I have the 4th root of what? Right? X plus 9, and then I have minus 6. What's my domain restriction here? What can I combine that 9 and the 6?
No.
Why? Good. That's as much as we can combine there. That's it. Because the 9 is underneath the square root and the 6 is not. But are there domain restrictions? Is there something that my 4th root cannot equal? It cannot be a negative number, right? So I have to say for my domain, I have to say, okay, the 4th root of x plus 9 has to be greater than or equal to 0. So 4th root on both sides. X plus 9 has to be greater than or equal to 0. So x has to be greater than or equal to negative 9. How would I write that as a domain? I need all the stuff that's greater than or equal to negative 9. What would that be? Well, think about it. If I graph that, I have negative 9, I have 0. It has to be greater than or equal to. So where would it start and where would it end? It starts right here at negative 9, right? So it'd be negative 9 to what?
Infinity.
Infinity. That would be your domain. Not the easiest thing in the world, guys. I know.